The question is, state and explain the principle of moments and describe an experiment to verify principle of moments. So, according to the principle of moments, the algebraic sum of moments of various forces acting on a rigid body in an equilibrium must be equal to 0. Let's say if there is a rigid body and there are a number of forces acting on that object, and if the body is in equilibrium, so according to the principle of moments, the algebraic sum of moments of various forces acting on the rigid body in equilibrium will be 0. In other words, we can say that the principle of moment states that if a rigid body is in rotational equilibrium, then sum of all the anti-clockwise moments about the axis of rotation must be equal to sum of all the clockwise moment about that axis. So as a result, the object will be having net force equal to 0. Now let us see the second part. So, consider a meter scale that is suspended freely from a rigid support by tying a thread at the midpoint, and weight W1, W2 and W3 are suspended from different points on the scale as shown here. We have to adjust the position of these weights so that the meter scale remains in equilibrium, means it remains perfectly horizontal. Now let the distances of these weights from equilibrium point be D1, D2 and D3 respectively. Now we know the moment due to weight W1 is in anti-clockwise direction, here we can see, and the moments due to weight W2 and W3 are in clockwise direction. So anti-clockwise moment will be W1 into D1 and total clockwise moment will be W2 into D2 plus W2 into W3 into D3. So we know that as the meter scale is in rotational equilibrium, so as per the principle of moments, the anti-clockwise moment will be equal to total clockwise moment, that is W1 into D1 will be equal to W2 into D2 plus W3 into D3. So from here we can explain the principle of moments. So I hope it is clear to you. Thank you.